So in today's class we are going to talk about the introduction of semester 2, but before we start, I think it will be better for me to give you a quick orientation about the physics 102 that we're going to be taking in semester 2. Physics 102 is not hard, at the same time it's not simple. They say there's nothing hard. As long as you follow simple steps, then you can do it. Okay, so then it will require I think the first 3 topics, it will require us to know the introduction. So when we know the introduction, we keep on building up. We keep on building up until we are done. And then when we go to the second session, again from the second session of the semester 2 up to the last topic, we also keep on building up, which the thing that could concern electricity, the capacitance, all those things are going to be just building up until the last topic. So I want us to cooperate. Like I said, as transcended, our goal is at least to cover half of semester 2 work. Okay, and I believe we are going to do that. Okay, so the way I teach, when I teach, and then we will be going back to the throw sheet, we'll refer to the throw sheet if at all we can be able to solve a question based on what we are going to do. Then again, we'll be going back to the past papers if at all we can see a question that is related to the topic we are doing, then we try to solve. So that's how I teach. So another quick thing that I wanted to mention is as transcended, we do not have classes every day for a very simple reason. These things that I'm going to teach you today, they are already there on website. The only thing that you are supposed to do is we are going to be solving the tutorial sheet. That's what I want you to understand. Can you just mute your mic? Can you just mute your mic? So what we are going to be doing is this. Every morning and in the evening, I'll be sending you the videos that you are supposed to be watching, and these videos are only found on website, and these videos can only be accessed by those students who are registered. Then you should also be checking the announcement that we put on top here. I think you can see here saying join our WhatsApp channel for promotion and class updates. So any announcement, sometimes we can post in the group, but you are going to miss it because of the messages, the load. But if you just log in, if there is any important announcement, it's going to be updated here. So if you click here, direct is going to take you to the WhatsApp channel. If you're not yet in our WhatsApp channel, follow this link on website. Whether you are not registered, you can still see this notification. You go on Google and type Transcended Stud Hub, and this is going to come. Okay, now Transcended Institute has been branded to Transcended Stud Hub, but it's basically the same thing, so don't be confused. So the orientation that I want to give you here, guys, is how are we going to be learning. Let's say today we are supposed to learn physics. Okay, then I'm going to be giving you instructions. So when you go on physics, I'll be telling you the specific videos that you are supposed to watch. So you scroll down, semester 2 starts from here, vibration and waves. So there are two, this vibration and wave, and then there's also vibration and waves updated. They are the same videos, but these videos for updated, they are more advanced and more simplified at the same time than the first part. So it's either you can watch both or you can choose which one to go. If you feel like vibration and waves you are not understanding, you can then go to vibration and waves updated, but it's actually the same content. So if you click on vibration and wave updated, And then the first topic is deformation of solids. That is the same topic we are going to do today. The second, simple harmonic motion, motion of the simple pendulum, physical pendulum. Then 2022 physics 101 question 4 exam paper. Then the throw sheet are also there. Then now, this is just the first topic. The second topic, just like that, everything is there. Okay? So when I tell you to say today, we are going to watch the first two videos, I'm going to be mentioning them. We're going to do deformation of solids and simple harmonic motion. When we are done, I'm going to send you the questions, and the questions I'm going to be updating them on website. Then you answer those questions, I mark. Then when we are done with that topic, that's when we are going to be having a class to just simplify the whole content. That's how we are going to be learning. Does that make sense, guys? So when we are done, for example, we are done with the first maybe 3, we even solve some questions, then I'll come back. We'll have a class. Then that class, I'll just now explain, or where you are failing to understand, I explain more. Then again, I'll be compiling more questions so that we solve questions. So the class will be more like solidifying the what? The topic. But if you have got questions, you are still open, you can still ask. So that's how we are going to be learning. I hope now it's clear. If you have got any question, so you can register through the website direct. You can just go direct on website, you register. But if you register using the website, most of the times the discount is going to be small. But if you register through the ambassador, sometimes you can get at least the best discount. Now, how do you register using the ambassador? In your group, inbox the admin. So the admin of the group where you are in, that is the ambassador for Transcended. So you can inbox that person, and then that person is going to help you. Make sure that the time you are going to make payment using the ambassador, you are going to use the number you are going to withdraw and not sending the money. So when withdrawing, it's going to show Isaac Ngoma. Okay? I think I've made myself clear there. Unless you have got a question before we start. Any question? Another question? Okay. Without wasting much of our time, side time. So, okay, let's start now. So, we are going to start with what we call deformation of solid. Yes, you can ask if you have got a question. Okay, you don't have a question. So deformation of solids. What comes in your mind when you're talking about deformation of solids? Deformation of solids falls under vibration and waves. One thing I want you to understand is that whenever we're talking about deformation of solid, you have got a solid, now you are trying to deform it. You are applying external forces. It's either you are expanding it or you are compressing it. A very simple example is if I try to hit the metal, that metal is going to expand. Sometimes you're not going to observe that it has expanded, but definitely that metal is going to expand. Have you ever come across a situation where as people who stay in Komboni, we are not going to relate, me, Gift, Richard, and 99 others, we are not going to appreciate this, but I tried this when I was at university. For those who have got, for those who stays where they have towels, do you know that they don't allow you putting the brazier direct to the towels? Do you know the reason? Okay, we have started learning now. We have started. That's where now deformation of solid comes in. Do you know the reason? Maybe tuanze tuchokera kuma compound, guys. Do you know the reason why they don't allow you to put the brazier direct to the towers?
No, we don't.
Ah, so you didn't ask the reason why they don't allow you putting direct there?
It could be maybe the organisms and they expand, there's the result of growth.
Exactly. That's the basic idea. That's where now deformation of solids comes in. There is only one course in first year that makes sense. The rest doesn't make sense. The only course that makes sense in first year is physics. Physics, we are talking about real stuffs. You can see them. Not mathematics where they say prove that 1 plus root 2 is irrational. Ah, it's not even making sense. So perhaps when you try to just a simple experiment, if you try to put the tiles, then you try to put maybe you heat it, it's going to expand. At the end of the day, it's going to break. So that is deformation of solid. Now that one we call it bulk modulus, but anyway, we're going to talk about that. So deformation of solids, in most cases we are going to be focusing more on what we call Hooke's law. Perhaps you have heard of this in grade 7. Hooke's law states that the resultant force is direct proportion to the displacement. In some other books, they will tell you to say it is the change in x. The change in x is the displacement. The simple example is this. This is the spring. If I try to compress this spring, it will be like this. I'm compressing it. If I try to stretch it, it will increase in length. So if you are trying to compress something, you are reducing the x. X is the length, and the SI unit for length is meters. Now since x is going to be changing, the resultant force is k times the change in x. In some other books they are going to put negative, but I'm going to explain where the negative is coming from. Okay, now this Hooke's law, I'll come back in subtopic number 2 to explain more on spring. But for today, I just want you to know that the spring constant is given by Hooke's law states that the resultant force is direct proportion to the displacement. So this is the displacement, x. K is the spring constant. K tells me how stiff or how loose the spring is. But I'm going to talk about K value. In fact, I'm going to talk about Hooke's law more when we start now simple harmonic motion. That will be now the next class we are going to have. But for today, I just want you to know that the resultant force, Hooke's law states that the resultant force is given by K change in x. So perhaps change in x is equal to the x final minus x initial. So x initial, what I mean is that this is the final displacement, this is the initial displacement. In other books, they are going to use this as L. Okay? They are going to use change in x to be the same as the change in L. So don't be confused. They are the same thing. Okay? Now, another important thing that I want you guys to understand from here is that if we try to apply a significant force, if maybe let's say this is the spring, this is the normal spring, I've not done anything. Now I try to stretch the spring, and then this spring reaches at this point. Now let's call that this is the maximum point at which the spring can be stretched. Okay, the maximum point at which the spring can be stretched when you leave it is going to go back to its original position. At that point we call it elastic point. You can be talking alone. We call it elastic point or elastic limit. So elastic limit is the point when you are trying to stretch the spring. When you release it, it's going to go back at the maximum or at the original position. Just try to do this. If you have got like a simple spring, try to stretch it. You reach at a certain point, then when you go back, when you reach at the maximum point of that spring, then you release it, you leave it, it's going to go back to its original position. At that point we call it elastic limit. So elastic limit is defined as the point at which the spring can go back to its original position after stretching. That is elastic limit. Again, there is a point where when you stretch, the moment you exceed the elastic limit, you are going to reach at a point that we call plastic limit. When you try to stretch the plastic, it will not go back to its original position. I want us to be relating. Even a spring can reach at a plastic limit. You stretch it, it's not going back to its original position. You have exceeded the elastic limit. Now you are at a point of what? Plastic limit. When you exceed the plastic limit, you go beyond the plastic limit, you are going to reach at a point where we call breaking point. So breaking point is a point where the spring is going to break into two pieces. At that point you have exceeded the elastic limit, the plastic limit. Now the next point is breaking point. So the spring is going to break into 2 points or 2 parts. At that point, the moment you are stretching something and then it breaks into 2 parts, just know that you have reached at breaking. You have exceeded elastic limit, you have exceeded plastic limit. Now you have gone to breaking point. But I've explained here, if you are not getting it, then you stay across. You are still I don't know if you are still across. So if they ask you to define elastic limit, plastic limit and breaking point, I believe you can define. The good part of physics is that you can use your own English. Does that make sense?
Yes, guys.
Okay. So now let's
Sorry.
hmm? Not what?
I think they're trying to say that repeat the points you're explaining.
Yeah. Okay, I'm going to explain. Don't worry. So this guy, we are saying this is in Hooke's law. Anything that obeys Hooke's law, okay, we are saying that when you stretch the spring, you reach at the maximum point, you release it, it goes back to its original position. What I want you to understand is that this spring obeys what we call Hooke's law. And this behavior of Hooke's law is what we call elasticity or elastic behavior. Elastic behavior, it goes in a linear way. Now, there are people who behave like elastic behavior. A situation where you are with someone today, they'll tell you to say, if we go to the bar today, if you buy alcohol for me, I'm going to be quiet on you. I'm not going to say anything. But now, just after 3 black labels, then the person now starts survey running. Hey, after all, you did this, hey, you did that. That person behaves in a way Hooke's law behaves, in elastic behavior. You can go back to your original position, you can go back to what maximum position, but at least be like someone who can act like what? Plastic. Because it will not go back to its original position. You are just standing firm. If you buy 2 black labels for me, I'm not going to do anything bad. Okay? Then again, you're not supposed to be behaving like breaking point. After drinking, you start now fighting. So that's the basic idea. But under this deformation of solids, there are only 2 things that I want you to understand. Okay? Now, this elastic behavior, which is Hooke's law, we have already explained, is now considered, is explained further into 2 terms. And these terms are stress and strain. But let's talk more about stress. So what is stress? The same stress, you know. You are fighting over a girlfriend. You are stressed. A girlfriend has texted you, no, today I want to go to Nando's. At least send me money. You are stressed. Stress is the same as pressure. Ah, that girl is giving me pressure. It's basically the same thing as stress. Okay? Now, this stress is force divided by area. And we can make this to make we can actually explain, and it's going to make more sense. Let's assume that you are a family pillar. Then you have got a lot of things coming up. Your mother wants this, your brothers want this, your sisters want this, within a short space. Okay? But the force is too much. So there is a force that is coming to you, that is the force that is coming to you, people telling you to say, I want this, I want this, I want that, I want that. And then within a short period of time, they want you to do that. You are stressed. So force over area. Now from here you can clearly see that stress is going to increase the moment when the area goes down. What I'm trying to tell you here is this. Area, just think of it in terms of period. Let's say someone tells you to say, I want you to give me 2,000 today before 17 hours. It's just within a short period of time. Now you're going to have pressure. So that pressure, guys, I said mute your mics. Who is this guy first? Frederick. So stress is given by force divided by area. So force is in Newton, area is in meter squared or square meter. So therefore stress is given by Newton per square meter. 1 Pascal is equal to 1 Newton per square meter. So pressure and stress, they are basically the same thing. Okay? Now let's talk about strain. So strain is given by the change in length divided by the length initial. In other books, they will tell you to say the change in L divided by the L initial. Others, they will tell you to say direct the change in length divided by the original length. So you choose which one to go with. Again, there is a relationship between stress and strain. Now let's talk about that relationship. So let's just put it here. We are saying that stress is equal to the force divided by area. Then strain is equal to the change in L divided by the L initial. In other books, I've told you that it is the change in X, because X they consider it as in the length, then this. Now there is also what we call the ratio of stress and strain is what we call the Young's modulus. So there is what we call Young's modulus. Young's modulus. Young's modulus is given by the stress divided by the strain. If I have the Young's modulus and the strain, I can find stress. If I have Young's modulus and strain, I can find stress. If I have stress and strain, I can find Young's modulus. In some books, Young's modulus is going to be represented by just Y. But in other books, they'll say Ym. Okay? So it depends with the books. So Young's modulus is given by, we are saying that stress is force divided by area. Then we divide it by strain is the change in L divided by the L initial. This can be written as F divided by A, then divide it by the change in L divided by L initial. At the same time, I know that this division is going to come to multiplication now. So F divided by A times the L initial divided by the change in L. Therefore, the Young's modulus is the force times the change, I lost my network, but I don't know if you guys were getting me. So you can tell me exactly where you stopped getting me so that I continue from there. So this is what I've written so far. I ended on what? Okay, so I said stress is given by force divided by area. And then another thing that I mentioned about stress is the same as pressure, because pressure is also given by force times area. Another thing is that when we're talking about stress is same as pressure. The same stress, I know I'm stressed today. I've been crashing on this girl, but she's just giving me shoulders. She doesn't want me. I'm stressed. No, girls will be like, no, that guy who stays in down school, he's tall, dark, and handsome, but he doesn't want me. I'm a bit stressed. But you can't crush on someone who stays across, eh? How can you crush on someone who stays across? So that's pressure. So pressure and stress is basically the same thing. Then there's also what we call strain. So I said strain is basically the change in length divided by the L initial. L initial is basically, so in simple terms, is the change in length divided by the original length. Now I don't want you guys to be confused, because in some other books this change in L, they'll say it is the same as change in X. So change in X, they will simply mean it's the same as the length and then divided by the X initial. But I want you to understand that this change in L, also known as change in X, is also what we call the extension. So when the question is asking you to find the extension, you are trying to find the change in L or the change in X. Okay? V, when I ask you to say what is the change in velocity, the change in velocity is the V final minus V initial from semester 1. It's basically the same here. Change in L is L final minus L initial. Again, change in X is basically the same thing, X final minus X initial. So don't be confused there. Now I said when I divide the stress, or the ratio of stress and strain, the ratio of stress to strain gives us what we call Young's modulus. Handwriting yaba biomedical scientist mwatipanga sensi. So the ratio of stress and strain to strain is Young's modulus. So let's talk more about Young's modulus. So we are saying that stress is force divided by area, then strain is the change in L divided by the L initial. So Young's modulus is basically stress divided by strain. So what happens in some books, Young's modulus is denoted by just Y. Stress is force divided by area, but again we divide it by strain, which is the change in L divided by the L initial. This division I can put it here, then I put these guys O2 this side. It's the same thing, I've not changed anything. I can change this. I'll say the force divided by area times then the reciprocal of this L initial change in L. If we multiply this, Young's modulus is given by force times L initial divided by area then times, now area, I don't want area to area times the change in length. So this is the formula for Young's modulus. What are the SI units for Young's modulus? Length is in meters, this length also in meters. So the SI unit for length will cancel, meaning I'll have Newton divided by meters, square meter. Again, Young's modulus, the SI unit is also newtons per square meter. What are the SI unit for strain? Who can tell me? Gift. What are the SI units for strain? Yeah? Meters. Gift. Gift has bracket. It has got no units. Yes, Dorothy, thank you. It has got no units because we have got length on top and length down. So length and length will cancel, or m and m, which is meters and meters, will cancel. So the SI unit for stress is basically the same as the SI units for Young's modulus. Now just from here, direct, if at all you have been given the Young's modulus, you can, and the stress, you can find strain, and the vice versa. Any question? Let's talk about this. Let us assume that this is our graph. Now this graph is going to be a graph of here I'm going to put force, then here I'm going to put distance. So force I'll put in Newton, then I'll put distance as x, as displacement in also meters. That's what I'm going to do. So let's say, now what I want you to understand is this. Or let me do this. Here I'm going to put strain, and here I'm going to put stress. So let's have a point from this point to that point, another point which is going to come from here, then it goes like this, it reaches here. So the point I'll put now A, I'll put B, I'll put C. From point A to B, from point A to B is what we call the elastic, or it follows Hooke's law behavior. I can say this is the point. Hooke's law, we say that it is kx. So this one follows Hooke's law from point A to B. That one is the elastic behavior. So it follows elastic behavior there, where the resultant force is direct proportion to the displacement. Okay, that's what I want you to understand. Yes, you are the only one. You can just leave the meeting and join again. Okay, so from point A to B, it is elastic behavior where it follows Hooke's law. Then at point B, this is where we said it is elastic limit. So elastic limit, we said, is the maximum point where when you stretch the spring, it will go back to its original position. From point B to C, this point is plastic limit. At point C, that is a breaking point. And I explained about this. That's why I said I'm going to explain again. Now, this graph is very important. It's going to show us something. Okay? Let me just go ahead and redraw it. Now, the graph that I'm going to redraw is the graph of the force versus the displacement in Newton, x in meters. If I have got my line here, we know that this obeys Hooke's law. Okay? Now, what I want you to understand is that it is possible I can find the k value, because we know that this linear one, it follows, it is this. It's Hooke's law. Then, what I want you to understand is that from here, I can also find the k. How can I find the k? I can divide both sides by what? By x. So k will be equal to the f divided by x. So the f is in y-axis. The y, or the x, is in x-axis, the way it is. So you can say it is the same as the change in y divided by the change in x. At the same time, you can just say direct k is the change in f divided by the change in x, and then I'm going to find k. So as long as you have got the graph and then they're asking you to find the k value, you can use this expression that I've told you. Let's go back to semester 2. Semester 1. Semester 1, you and I agreed that work is given by force times the distance. Now in this case, distance is x. To find the work, whenever we're talking about the graph, it is the area under the curve. So how do we find the area under the curve? In this case, it is the shape. This shape is triangle. Then it is half BH. So where there is A, put area. Okay. So we are going to put now, where there is A here, I'll put what? The work. Because we are saying that the work done by that force is the same as the area under that curve. So half BH. B is this one. This is B. This is H. But again, in this case, in this context, H is F. B is X. Let's replace now. Work done under the curve is half. B is X. Then H is F. If I take you back to Hooke's law, we said that Hooke's law states that F is equal to Kx. Where there is F, let's put Kx. This is going to be equal to, so now we have got X, then we have got Fx. X and X are not Fx, Kx, right? So we have got Kx. So X times X is X squared. So the work done under the curve is going to be, so it will be Kx times X squared. This is the formula that we use to find the work done whenever we are talking about the spring constant or the vibration and wave. So the work done is given by half Kx squared. Who has got a question based on what we have done so far? Yes, it's the gradient. So it's not more like, but it's gradient. So under the curve, when you are finding the curve value, it's the same as finding the gradient. Are we good to go? Yes, yes. The k is equal to the gradient under the graph. Is that okay? Now I want us, some things should be making sense. I hope no one is confused here, because I want to show you something. I want to show you a question that I think I want you to be convinced that at least from what we have covered so far, you can solve. Question from tutorial sheet 1, physics 102. A spring that obeys Hooke's law. So whenever they're talking about a spring obeying Hooke's law, we're talking about this. So here is a graph, and this spring is just straight here. Hooke's law, it is always in a linear manner. So a spring that obeys Hooke's law has a spring constant K. Show that the energy stored E in the spring when it has been extended elastically by an amount X is given by work is equal to half Kx squared. They want you to show where this formula is coming from, and I've explained. I don't think there is anything difficult here. Who is not convinced on how I've showed you that this work done by the curve is equal to the area under the graph, and we have come up with that formula? So this is how you show. Mukundimva? Okay. But again, there is another way now. That one is under calculus. There is another way on how you can also come up with this formula, but it's under calculus. But for those who are interested, so we have come up with one on how you can show that this is equal to that. But again, we can also show using a calculus way. So work is equal to force times distance. The distance in this case, we are talking about x, right? So in that case, work is equal to force times x. Okay, now what I want us to do is I want us to integrate with respect to x. So it will be y, or w, is equal to the integral of fx, then I'll put dx. So we are integrating this with respect to x. Now the integral of x is basically x squared divided by 2 plus c. You know this is going to be your food now. So the integral, if I tell you to say the integral of maybe 2 dx, this one is going to be 2x plus c. So the integral of x in this case, because f is constant, we are assuming that f is constant, so that becomes now f. Then how is it going to be? Let's do this. I don't want you to be confused. So whenever you are trying to integrate here, now what happens is this: we are integrating this with respect to x. So then this x becomes dx. So it will be the integral of f, then dx. So when you are integrating with respect to x, what happens? But first we can now replace f with kx. So now it will be the integral of, because f is kx, then dx. So if I integrate this, it's going to be, we are, k is constant, so we're integrating now x. So it will be now k, then x, the power increases by 1, you divide it by the power. So then work is equal to, if something is divided by 2, it's the same as half kx squared. So this is also, that's how the formula is coming about. But always the best one is this one. This one is just for calculus. This one is for those who understand physics. So the best is to show that the work done is given by half kx. We are talking about this formula. It comes from this diagram all the way to this. Does that make sense? It feels so nice when you learn and then you go back to the throw sheet, you answer a question. From what we have done so far, it is possible we can answer this question. A variation, that is to a variation with the extension x of the force F for the spring A is shown in the figure below. The point L on the graph is the elastic limit of the spring. So here is the graph. So we've been given F in y-axis, then this displacement is times 10 to the power negative 2, because they have put here in meters. The first question is, describe the meaning of elastic limit. I've explained this already, and I explained 3 things. I explained elastic limit, I explained plastic limit, I also explained breaking point. So elastic limit is the point at which the spring is going to return to its original position when the external force is removed, or when when the external force is removed, because the external force is the one that you are using to stretch. Calculate the spring constant Ka for the spring A. Gift. This is where now you asked me to say, is it the same as gradient? I said yes, not so. So under the graph, K is the same as the gradient. But me personally, I'll just tell you to say K, F is given by Kx. I'll divide it by K. I'll divide it by K. I'm finding K. How come I'm dividing it by K? F is equal to Kx. I'll divide it by X. I'll divide it by X. I'll pick any point because K is going to be constant. You can pick any point. Any point. If I want, I can pick this point, 4. So now my X, I've picked 4. It will be 4 times 10 raised to the power negative 2 meters, because here I've been told that I need to do times 10 to the power 2, negative 2. So look at this. This is 4. Now this 4, I need to take it direct now this side. What is going to be my force? So this is 2. So 2 meaning in between is 3. So I need to count 5. 1, 2, 3, 4, 5. So this is going to be 3. Meaning that this is going to be 3.2, 3.4, 3.6, 3.8, then 4. So this is now 3.2. So meaning that my force is 3.2. I divide this by what? We are dividing it by what? We are dividing it by 4 times 10 raised to the power negative 2. What will be the answer? So 3.2 divided by 4 times 10 to the power negative 2. And I'm getting 80 as my K value. Newton per meter. I can pick any point and I'm going to get 80. So you can either use this or you can use the one for gradient where you are going to change the change in y divided by the change in x. You still get the same answer. The answer is going to be the same. Then now the question goes further to say, from what we have done already, that's why I like this. Calculate the work done in extending the spring with a force of 6.4. So we go back to the graph. Where is our 6.4? Then we see how we can find the work. And we have come up with the formula for finding the work already. So where is 6.4? Let's go back and look where there is 6. So this is 6. So we are going with 2, 2. This is 6.2. 6.4 is here. So now I need to go direct here. 6.4 is here. This is the line for 6.4 here. Now down here it will go direct to what? To 8. Here, 8. So remember we said that work is equal to half kx squared. So we have half, the k value is 80, then the x value is 8. But don't forget to put times 10 to the power negative 2, because here we have been told that it's times 10 to the power negative 2. Again, you square it. So what will be our work? 0.5 times 80 times 8 exponent negative 2, then I square it. And the answer I'm getting is 0.256 joules. As simple as that. Nothing complicated. Now, I like to check also the past papers, not only the throw sheet, but also the past papers. Do you think we can also answer, based on what we have done, we can also answer some questions from past papers? Yes. (2023) exam question 1. And it was asked like this. It was under the first introduction. A steel spring has a spring constant 150 Newton per meter. When a 25 Newton weight is hung from the spring, it has a stretched length of 55 centimeters. What was the original length? Now remember what we talked about there now. Talking about original length. So remember what we said. I can just come back here and gather my data. So our data goes like this. We have been given the force to be, I've forgotten. We have been given the force to be 25, the spring constant 150. Force to be 25 Newton. Then the spring constant, which is K, 150 Newton per meter. Now what do we know? We have been given, now I want you to understand, what do you think this is? Is this the change in length, the L initial or the L final? It has a stretched length of 55 centimeters. What is this? Who can tell me this? L final. So that's the L final. Someone is also asking, is that not the extension? Yes, it's the L final. That's what we are saying. So that is the L final. So we are going to put L final here. So L final, we said, is basically the same as again X final if you want, which is 55 centimeters. Let's convert it to meters, 0.55 meters. Now the question is, they want us to find the original length, which is the L initial or the X initial. So the change in length or the change in X, at the same time you can say the change in X is actually, so should I use L or X? Which one do you want me to use? Anything? Let me use change in X. Change in X is X final minus X initial. My goal is to find the X initial. I don't know the X final. Sorry, the change in L. But remember we said Hooke's law states that K times change in X. Then I can find the change in X by dividing it by K. So the change in X will be F divided by K. So the change in X will be equal to, what is F? F is 25. What is K? K is 150. So therefore the change in X will be equal to 25 divided by 150. That gives me 0.167 meters. Now let's make L initial as a subject of the formula. Shift it to the other side. Shift it to the other side. What's going to happen? Are you still here? Are you still here, guys? Are you still getting? Yes, so I'm trying to find the change in what? I'm trying to find the change in the L initial. So I'm going to shift this to go to the other side. So that becomes XL is equal to X final, then this one goes to the other side minus the change in X. So I already know X final to be 0.55 minus 0.167. And what will be my answer? So you say 0.55 divided by or minus 0.167. That becomes 0.383 meters. So this was our original length. If we go back to our question, we check if at all we have got such answers. Let's see. So 0.38 meters, that is C. So have you seen that this guy went with B? So this guy did not register with transcended. That's the reason why he went with B. So he got it wrong. And he was confident that he has gotten it right. But because he was not with transcended, he managed to find 0.61. But for those who were with transcended by then, they managed to find C because they were even smiling after the exam. So initially, this is what you are supposed to know under deformation of solids, nothing more. So the first part, we are done. Next, we are going to do the next part. But tomorrow we are going to have math. Tomorrow we are going to do math. So, and tomorrow is going to be only for those who have registered. So do not hesitate. Like I've told you guys, take your time, register with transcended. Yeah, definitely you'll be able to. So get in touch with the admin of your group, the ambassadors. They'll be able to help you, because this one is going to help you a lot. Look at this. Let me show you. If you look at the past papers that I solved for semester 2 already, I solved the thorough sheet, the past papers, and they are here. They will help you to understand a lot of things. if you look at this, from 2018 to 2023 exam past papers, then and other ones, they are also here, plus the throw sheet. So all the topics, the throw sheet, they are also there. You'll be able to access them. So let's be together, register with us. I hope everyone is in the group for Transcended, right? Yes, you are there. If you're not in the group, find yourself to be in the group, and then you'll be helped. Unless you have got questions, you can ask me before you go.